Every time I have a conversation with you, I'm just learning more and more. I think you probably have a great future in terms of being the TED Talk of the plastic to fuel industry. That could be a nice side hustle also for you.
A lot of people whose plants don't work in plastic to fuel industry, all of them have given TED Talks, but the from AP CHEMI, we have not delivered a TED Talk yet. So let's see.
Very, very good afternoon to you, Suhas. Suhas Dixit is joining us all the way from India, and he is the founder of AP CHEMI. Now, these guys are leading the charge in terms of plastic to fuel. They are also mentored by Shell as well as the Alliance to End Plastic Waste.
Thank you for having me here. We are a technology and plant suppliers to convert plastic waste into oil, which can be used as fuel as well as a feedstock for production of circular economy plastics.
For those who have no idea what plastic to fuel is, can you give them the short, simple answer?
And plastic is produced from crude oil. If you take plastic to temperatures of around say 500, 600 degrees Celsius, it breaks down into oil. And then you have two choices: either use that oil as a fuel or use it as a feedstock for plastic production.
So, the greatest pushback that I commonly encounter against plastic to fuel solutions are that plastic to fuel perpetuates fossil fuel, and that at a time of reducing carbon emissions, it's like trying to introduce another kind of low sulphur but still fossil fuel. So do fuels made from plastic make sense or eco sense?
The carbon footprint that gets generated out of fuel production from crude oil, which includes of crude oil excavation, transportation, refining and all, that carbon footprint is same as the carbon footprint of plastic to fuel, which is plastic collection or conversion using pyrolysis as a process. So carbon footprints are very similar. There are a couple of reports which say that the carbon footprint of plastic oil is 15% lesser to the carbon footprint produced from crude oil. So there is this Argonne National Laboratory which says that carbon footprint of pyrolysis oil is lesser than crude oil sourced fuel.
I mean, for a startup, right, this is something that really takes a lot of funding and a lot of connections and know-how, right, to be able to even create the factory-sized plastic to fuel or even tire to fuel facilities that you build. So what was the social impact impetus that led you to this?
When I initially started working on this, I made smaller pilot plants of plastic to oil, put them in the back of my car, showed it to a bunch of municipal corporations and started gaining a little bit of traction around. And that is like around 2007 I'm talking about. But then from there, some interest got generated and somebody ordered a 5-liter reactor vessel capacity plant with me, and then somebody ordered 10 kilogram plant and 100 kilogram plant and 1 ton plant. And that's how we kept organically growing by helping people kind of come up with these initially much smaller versions of plastic to oil plants.
As an engineer, you could have had your choice working with any other MNC. Why start a startup?
It really boils down to what you want to do in life, right? I thought that solving plastic problem can add value to what I am doing and what we can contribute as a company, as a sustainable business model, as well as a solution for managing plastic waste problem.
So the thing that's interesting is that the plastic industry, there's been a lot of knowledge base around that, and then of course the oil and gas industry, right? There's a lot of processes around that, but plastic to fuel is still in its infancy in terms of an industry, right? So how do you grow that knowledge base for your own engineers?
People knew since last 30-40 years that if you take plastic and take it to temperature of 600 degrees Celsius, you do get oil. But then to commercialize this technology is an entirely new challenge. And when we say a multidisciplinary engineering team, we have process engineers, we have got electrical engineers, mechanical engineers, automation engineers, safety engineers. So we have a team of 20 design engineers. So each design calculation needs to be done, needs to be simulated, needs to be verified by a pilot. It's a painfully slow process to verify each equation and have each part of the chemical process plant and each design validated so that it functions commercially. So it's a gradual process, and yes, it does take number of engineers of various discipline to make it happen. Yeah.
Something that I also wanted to mention, entrepreneurs are known to be notoriously impatient. In that spirit, can you share with me what are the top 3 things that are irritating you right now?
Markets like us are legislation driven. Laws get implemented for recycling. The recycling as a sector will do very well. One is how fast do the recycling related legislations or plastic tax related legislations get implemented. That's the first thing. The second thing is that to ensure that plastic waste management happens, there are multiple stakeholders. It does take a lot of time to solve these kind of challenges, especially because a lot of stakeholders involved. It's that things don't happen as fast. So these are the 2 things: legislation implementation, having multiple stakeholders for plastic waste management project. I'm not sure of what is the third, but these 2 I can come up with.
The other biggest thing is about safety and environmental impact, especially with the release of hydrocarbons.
To begin with, there is no leakage of hydrocarbons. All our projects are operating with necessary government permissions, and they are not releasing any hydrocarbons in the environment. Environmental compliance in chemical industry is a known subject, and a lot of expertise is available on, let us say, if a particular quality of emission is coming out, how can that emission be cleaned before releasing into the environment? We know how to comply with the environmental legislations by ensuring that the air, water and solid emissions are in line with the directives given for that particular country. At the same time, another subject is safety. So safety in chemical process plants is established by a process called HAZOP analysis, as well as safety integrity study. We have the necessary instrumentation or control or equipment design to ensure absolute safety when these plants operate commercially. There are really 2 types of companies who supply chemical process plants. Those who don't worry about safety, worry about just making business out of it. And at AP CHEMI, we've learned to ensure that the safety is the priority, and a sustainable business model is a byproduct of ensuring safety.
Thank you so much, Suhas. So I just have one last question to go. For those who are, companies or countries or even, as you mentioned, municipalities that are trying to figure out, is plastic to fuel a solution for them?
Every year, 300 million tons of plastic waste is generated globally. Around, say, 200 million tons ends up in landfills, rivers and ocean. Less than 9% of plastic waste today is mechanically recyclable. You are left with either dump it into the landfill or incinerate it. And when you incinerate it, there's huge amount of carbon that you send to the environment. So a lot of investments still are coming in incineration projects or waste to energy projects, but that is not really environment friendly. Now, how do you take the plastic waste, which is not mechanically recyclable, and put it back into the circular economy? Out of all these technologies, what we know as pyrolysis is the most suitable for variety of mixed plastic waste. For those countries or council offices or municipal corporations, they should ideally go through a formal exercise of a pilot plant trial, trying out, let us say, 5 kilogram of plastic through different technologies, and what comes out and what is the cost of converting plastic into end products using these various technologies. At the same time, what is the carbon footprint on the environment?
Terrific. Thank you so much, Suhas. I mean, I think it's a degree's worth of information, right? Condensed into one conversation. Thanks everyone for joining us. This is the Opportunity Series.